Welcome to lesson 7.25, looking at dividing fractions. Today we're going to take a quick review of understanding the principles of really a keyword known as reciprocals. And our first example really helps us understand reciprocals. As we look at our first example, we see we have 1 divided by 2/5. And so the question that we're wondering here is how many 2/5 pieces actually fit into 1. If I were to draw a quick picture here, I can draw a complete circle. And of course, fifths aren't the easiest thing to draw, but I've worked on it over the years and I'm doing just okay. But the question would be is how many of these fit into here, right, this one. And we can use the process of understanding reciprocals to solve this problem. And so in general, what we're going to do is to divide by a fraction. To divide by a fraction, we're going to multiply by its reciprocal. And so we're going to take 1, there it is, and now we're going to multiply by the reciprocal. The reciprocal, of course, is taking this fraction here, and we're going to invert it. Sometimes this is actually known as the multiplicative inverse. I know that's a big word there, but it helps us understand it. It's inversing it. We're flipping it, I guess, is the quick word to say it. And so if I flip it, I put the denominator on top and the numerator on bottom. They switch places. Now I have 1 times 5 halves. And of course, anything times 1 equals itself. And so I get an answer of 5 halves. And so what we see is we see a relationship between this fraction and this fraction, because if I were to work backwards, if I were to take 5 halves times 2/5, then I would get an answer of 5 halves times 2/5. I'm going to get an answer of 1, right? 2 times 5 is 10. 2 times 5 is 10. 10, of course, equals 1. So we've proven the fact that this reciprocal is our key part, right? So reciprocal. Important word. All right, let's take a look at a similar idea now. Of course, our second example here is we're not taking 2/5 and putting it into a 1. Now we're taking 2/5 and we're putting it into a 3/4. However, since we understand that this 5 halves down here is how many fit into 1, now we can use that reciprocal to solve this problem. So we're going to take our fraction, instead of dividing, we're going to multiply, and we multiply by this fraction's reciprocal. This one's, not the first one. The first one's going to stay the same, and instead we're going to multiply by the reciprocal, which is going to be 5 halves, which we just solved for in our first sample. And so in the end, as we solve this, numerator times numerator gives us an answer of 15, and 4 times 2 gives us an answer of 8. From here we have an improper fraction, and we're going to simplify. 8 goes into 15, of course, 1 time, and I get a remainder of 7/8. So we have this process that we're going through here. Let's continue on. Of course, sometimes we want to see a little picture to help us understand this idea. It says Sam walked 9/10 of a mile to school. On his way, oh, I cut off some of the words. Let me scoot them over so you can see them. On his way to school, he passed a bank which is 3/4 of a mile from his home. What fraction of his walk has Sam completed when he reached the bank? All right. So it takes him 9/10 of it. On his way to school, he passed a bank which is 3/4 of a mile from his home. What fraction of his walk has Sam completed when he reaches the bank? Okay, to solve this problem, we need to kind of understand the big picture here, right? We understand that it takes him 9/10 of a mile, right? So this is the whole distance that he needs to cover. And if we think about this whole distance is very similar to like the denominator of a fraction. Now we also learned that 3/4 is what he's covered. That's where he got to the bank. So this is part of the distance that he's covered. And so what we've really created here is what we know is known as a compound fraction, right? A fraction over a fraction. And of course, a fraction over a fraction really is saying this, is I want to divide 3/4 by 9/10. And from here, now that we understand how this works, now we can say, okay, now I know how to solve for this, because I'm going to take 3/4 and I'm going to multiply by the reciprocal, which of course is 10 over 9. Now I could solve this problem real fast, but hey, wait a minute, didn't we just learn something about reducing before multiplying? Check this out, right? I'm noticing that this is an even number, 2 times 2, and this is also an even number, 2 times 5. So if I get rid of the 10 and the 4 here, also my 9 I can break down into 3's. Right? So now I take this 3, and this 3, and this 2, and this 2, and suddenly I'm left with everything that I need. So I can actually reduce before multiplying. And so I finally come away with 5 on the top and 6 on the bottom. And so in the end, what fraction of his walk? He's done 5/6 of his walk. Don't believe me? Okay, 3 times 10 is 30, right? And 4 times 9 is 36, which means I can take a 6 out of both of them, divide by 6, divide by 6, and of course you're going to come away with an answer of 5/6. So both processes would have gotten you to this correct answer. Your turn. Go ahead and solve this problem. Remember, you can't reduce a fraction unless you're multiplying. So you can't reduce a division problem and then find the reciprocal and divide. You must, first of all, find the reciprocal, multiply by that reciprocal, and then if circumstances work out, you can, of course, simplify before multiplying. Okay, I think that's enough for me today. Best of luck. This is lesson 25.